Hey everybody, this is Larry. This is me going over Q4 of the weekly contest 389. Minimum moves to pick K1s. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. This one was very hard. I did spend about half an hour debugging just because I was just sloppy. And you could watch the live portion and kind of watch my debugging. I think it's actually kind of pretty interesting. But yeah. Yeah, basically, I think the hardest part about this initially is just to understand the problem. And yeah, I had a couple of ideas. I'm going to go over how I thought about this problem. So, that, because look, listen, anyone can just go over the solution, right? I mean, that's fine if you only want the solution. But I think for me, and this is one of the reasons why I have this channel structured like this, because people ask me this all the time, is that for me, it's not. I think it's easy to kind of it's easy to make a mistake of confusing understanding a problem with being able to solve a problem, right? And yeah, okay, maybe like on the and I think that's like a something that people maybe pick up as they're learning is that. Especially in the beginning, they're like, oh yeah, just memorize this pattern, memorize that pattern, and memorize this other pattern, and just like, go it out. And yeah, of course, if you only have to remember everything, then, when you understand something, then you can just, because understanding is, your definition of understanding is memorizing it, then yes, you can, when the problem requires you to do the exact same thing, yeah, you could get the exact same thing. But for me, even when I get the right answer, I will very often look at other people's solutions just to see how I can learn and be better, right? And so for me, my value add is not just be like, oh, here's the solution. There are a lot of YouTube videos that people also, just make kind of dubious Leetcode submission, editorial submissions, but that's besides the point. So you could definitely understand the problem in other ways. But what I want to do is kind of go over how I attack the problem and hopefully in a way that kind of sparks like, hey, this is how I think, and not just, like, hey, this is a DP problem, or, and then you just kind of copy and paste and kind of play with some digits until, yeah. But okay, let's go over this problem real quick. And I think, yeah, like I said, the problem is kind of confusing, to be honest, but basically you have a lot of ones and zeros, and the way that I actually initially thought about it is that I really thought that maybe there's what I call a sweep line solution, right? Basically you start here and then you sweep, and the thing is that with that idea, the idea is that okay, there's going to be, and just to be clear, the constraints are pretty big. N is like 10, I don't remember, 10 to the 5th, I think. Yeah, n to the 5th. So you have to do something subquadratic, right? Like n squared is going to be too slow, and also the solution is too obvious. So you have to do something better than that, right? So yeah, so that means that if you kind of think about it this way, if we look at every element, or if you kind of do a sweep line for every element, that means there's going to be n of them. And that means that for you to do slower than quadratic time, you can only do at most log n operations per incremental change, right? With the sweep line, and usually these kind of solutions, basically you keep track of a lot of things, and you could change the state of things very quickly using log n or one operations, depending on how it is, right? So that's usually the idea. And I kind of explored down this path for a little bit, and to be honest, I couldn't figure it out. So I kind of did it another way. And this part is kind of super hard because I don't think I would have been able to come up with it. The only reason why the reason why I say this is because there was a similar problem. I think someone called like minimum number of moves to swap ones or something like this, a variation of that. Because I was studying even though I got it correct, and I think I won that contest, to be honest. Like I've only won 2 contests, so like I think that was one of the contests that I had won. So but even winning the contest, my solution was kind of like there's a lot of cues and stuff like this. It was kind of a lot of bookkeeping and tracking. So I was thinking along those lines, but I couldn't get it that way. But I do remember learning it afterwards. There's a trick, right? And we'll go over that in a sec. But yeah. So instead of doing it this way with sweepline, I still just do it a similar way, which is that let's just say we still, it's not a sweepline because we don't do incremental changes. But now let's just say we have to look at each index once and check the answer. Can I get an answer in O of log n time, right? Still, the visualization looks kind of the same, I admit, but it's all about up in your head and how you approach these problems and the texture of the problem and how you feel around the problem, right? And okay, so to be frank, if it has to be log n, it has to be prefix sum in some way, right? Oh, sorry, spoiler alert. It has to be binary search in some way. And I'm not saying that, and at this point, I don't know that I can binary search, but binary search is one of the tools that I am able to do that is fast enough, right? So okay, so let's say if I want to explore binary search, what am I doing, right? And that's basically the idea that I had for this one. Is that okay? Let's say we look at this index, right? And now, and there's some things with what's it called, max changes or something. Yeah, we're gonna ignore max changes for this one for a little bit. We'll show you how to. With the code, we'll show you. It's just more edge cases, but yeah. But basically, let's say we're looking for, is it K that they want? Yeah, K ones. So let's just say we want 5 ones, right? 5 ones. Then here, the idea that I had was just to do a binary search on left and right, on equal length left and right? So then here, maybe I could go, okay, what is the length of this? But basically I go, okay, let's just say our first try is 4. That means that we will try 4 to the left, and this part it doesn't have to be so precise. It just depends on how you structure your thing. As long as you're consistent everywhere, it should be fine. But yeah, 4 to the left, 4 to the right, and then now this gives us 1, 2, 3, 4, 5, actually 5 ones, right? So then now we know that, yeah. Now 4 to the left and 4 to the right is good enough. Then now we try a smaller number. This is a binary search, right? So then now we try 2. We know that this is good, so I'm going to circle it in green. And then now we try 2, right? So then now 2, we do the same similar thing. You have 2 to the left, 2 to the right, and here the span we have 4 numbers, right? So 4 is no good. So now we try a bigger number, 3. This is just binary search, and that's basically how I do the binary search, right? Okay, so far so good on the binary search idea, hopefully, because I think that this part is I think is manageable, right? Yeah, I think this part is manageable to understand, because in order to solve this, you need a reasonably good idea of binary search. So this is where apparently Lenny on my server also kind of has a different similar idea, but he did it with Fenwick trees, which is, I guess, prefix sum anyway, right? But the idea for me is just using prefix sum. And it's kind of funny because I feel like we've been doing prefix sum all week if you've been doing the dailies, right? And the idea here is just with prefix sum, and I'm going to go really quickly because we did prefix sum all week. So if you came just to here, then I'm sorry. But the idea here is, with prefix sum in general, is that we calculate the sum of the number of ones from the beginning all the way progressing to the right? So then that means that this is going to be, let me change the color real quick. This is going to be 0 for no elements, then 1, 1, 2, 3, 4, 4, 5, 5, 5, 6, 7, right? So then now you have this prefix sum. And then now you could get those segments just by using prefix sum. For example, if you want this segment that why did I choose the same color? Sorry, friends. Let's say I'm choosing this pink color, right? For these 4 ones or these 4 spaces, then now this is just maybe I'm off by 1, but basically it's just this number minus this number, right? Because that's just how the prefix sum works. Because it's saying maybe I'm off by 1. Sorry. I think it's actually this one minus this one, because this number is saying that it includes 3, and then it includes 0 on the left. And the reason why you could the 0 is actually kind of terrible. Okay, let me try a different example. So let's say we have this span, right? The reason why, and this span is just equal to this span minus this span, right? So, or interval. I say span like so this, the pink area, is just equal to this area subtract by this area. So that means that it is subtracted from here, subtracting here. So then you get 2 as the answer, right? So that's basically the idea for prefix sum. Okay, so far so good still, hopefully. I know that I'm going very fast on the prefix sum part, but we've been going over it all week. I recommend doing the daily problems over the last 3-4 days, and then check my video if you haven't done it, because I think they all operate on prefix sum, and I don't know, there's still a harder part to this, at least to my solution. So I want to get through it and not spend like an hour on this video. But yeah, okay, right? So now, okay, fine, right? Let me erase a lot of stuff real quick, right? Okay, so then now it's fine, right? But that's not good enough, right? Is it? Because I don't know, I'm just writing new 1s and 0s. Sorry. This is a pattern, I think, but okay, fine, whatever, right? But basically the thing is that, okay, let's say we're still on this index, or this is just an index, right? The thing is that counting it is not good enough. Let's say we want 4, so in this case it will be 3 to the left, 3 to the right, and this actually gives you 5, which is an edge case that we'll talk about later. But right? But this isn't the answer. 2 is not, this is 2 to the left, 2 to the right, but sorry, 3 to the left. I can't count. But that's not the answer, right? The answer is actually, this 1 goes to 2, or plus 2. 2 moves to go to this one, and then this one takes 3 moves to go to this one. This one takes 1 move to go to that one, and then this one takes 2 moves to go to this one. So in total, you have 2 plus 3 is 5. Oh no, this is plus 3 again. Sorry, I cannot add. 5, 6, 9. Right. So you have 9 moves. 5 from the left and 4 from the right. Right. So that's the answer, right? For this, if we pick this index, the answer is 9, not the width of the thing. So this is the part where I said, I gave a little spoiler about, this is where I picked up the trick from. The way that I visualize this is kind of tricky, but basically, okay. So let's index these, right? So this is index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So that means that, okay, the index that we care about is 6. There's an index at 3, 4, 7, and 9, right? And of course, this is what we said, right? This is 2, this is 3, this is 1, this is 3, right? And that's how you get 9, right? As a total. So this is the hard part, or one of the hard parts, I guess. Is that, okay, so then how do you get 9 from this? The way that I do it is with a visualization trick. Well, that's how I remember it. Maybe there's another way of explaining it, another way to kind of understand it. But this is the way that I understand it. Is that, okay, you have 3, 4, and 6, right? So let's say you have, so let's plot this out, right? All right, let's just erase the top. Okay, I think you understand the top, hopefully. If not, then rewind and rewatch it again. But now let's say we have a line, right? Oh, sorry, a graph, right? And then now you have one at 0.3, you have one at 0.4, and then one at 0.6, and then 7, and then 9. And they're roughly accurate, right? So the way that I thought about this is that, okay, this is length 3, this is length 4, this is length 6, right? But that's not what we care about, of course. I mean, this should be obvious because, this is 0, right? Let's just say this is 0. But it means that this is 3, this is 2, right? Oh, sorry. Yeah, 3 and 2. So what do I do? Well, and I'm only I'll focus on the left for now first. That means that if we have a way to sum up all these indexes, then now we know that the blue parts, or the green parts, let's say, the green parts, if we have a way to get them quickly, that means that this is going to be 7, right? But because they're 2 numbers, you know that from here going this way, it's going to be 12 because it's just 6 times 2, right? So then now, to get the red numbers, well, now it's just 12 minus 7 is equal to 5, which is the sum of 3 and 2. It's, I hope the visualization makes sense, but that's basically the idea. I mean, the way that I actually think about it, honestly, is almost like an integral, and you could think about the blue parts as an integral, it's a discrete integral, if you will, which is what sum means, I suppose. But yeah, and then I kind of subtract in my mind, there's this idea of an area, and I subtract these and add these. So yeah, so then now I know that if the midpoint or the point that we're getting to is 6, we can just subtract the values themselves of the indexes to get the one on top. So yeah, that's how we get 12 minus 7 is equal to 5. Did I mess this up? Oh, no, yeah. 2 plus 3 is 5, so that's what you get. Same idea on the right side. I'm going to choose a different color, though. Same idea on the right side, right? Is that, okay. Down here is going to be 7 total. Down here is going to be 9 total. But here we intersect at 6, right? So that means that the 6 times 2 is going to be 12, same thing. But then now, let's say we have a magic thing to get 7 and 9, right? So 7 plus 9 is going to be 16, and then 16 minus 12 is equal to 4. And that's how you get this side, right? Same idea. Same idea, but going over instead of under, right? And that's pretty much the idea. And then now, how do you get the sum of 3 plus 4 or 7 plus 9 very quickly? Well, let's go back to, I guess it's too late to go back. But yeah, but that's, what is it, 3, 4, 6, 7, 9 or something? Oh, what the, let me try again. So you have 3, 4, what's it, 6, 7, 9, right? And then you have other numbers that, you have other ones. Let's say you have a 1. Okay, let's try this again, right? So you have 1, 1, 0, 1, 0, 1, 0, 1, and then maybe I have a 0 at the end, and just something like this, right? And maybe add an extra 1. Okay, right? And these are the ones that we care about. The ones that we don't care about, I'll put it in red. So like this one is a 1, and this one is a 11, right? So then now we can actually do a second prefix sum only on the indexes containing 1. So then now you have a no set in the beginning. So you have 0, 0, 1, 1, 4, 8, 8, 14, 14, 21, 21, 30, 30, 41, right? So then now, we know that we want to go 3 to the left and 3 to the right, right? Did I mess this up? Oh, I had an extra 0, sorry. That's why I messed up. Whoops. So ignore this. Sorry, friends. I guess I don't know why I have to draw it out. I can just like erase this. Sorry. As you know, there's no numbers between 6 and 7, or at least no integers between 6 and 7. But yeah, you go 2 to the left and 2 to the right, right? So this is the same prefix sum idea as getting it from here. Oops. From here. Right? So then now, you know, to get the sum of this span, it's just you go to 30 minus 14, right? So this is going to be 16 is the sum, which is 7 plus 9. And here is 8 minus 1, which is the sum is 7, right? And of course, you do the math about, you know, what we said before about 12 minus 7, 16 minus 12, right? And then now you have 5, 4, you have 9 in total, and that's your answer. Yay! Almost. One more case. So I don't know if you've already forgotten, but I said that k is equal to 4, right? But we got 5 numbers, or 5 ones. We have, changing color. We have 1, 2, 3, 4, 5 ones, right? So then what? What happens? Well, I mean, so then now you just count. You have 2 things on the left, 2 things on the right. Well, you know, you have 5 numbers. You need, so you need only 4, or you only, sorry. We have 5 numbers, right? And it turns out that you can only have an extra number, and you could kind of prove to yourself, I am going to leave the proof to the viewers at home, is that if you kind of minimize the range, that means that if you can have an extra 1 only if the furthest index are both 1s. Because you can do some kind of contradiction thing. Because if one is 0, if one of them is 0, then by definition, if you have enough, then that would be your answer. You don't have an extra one. If you don't have enough, then you would go further, and that would just be like a contradiction thing, right? And obviously, they cannot both be zeros, because if they both have zeros, then it's not monotonically, or I guess it is monotonically increasing, but it's not your minimum answer, right? Because if you have both zeros, then you just shrink it by the size of 1. So yeah, so that means that you can subtract just one of these, and here, and we know what the index is because this is 2 spaces away, right? So that means that for 6, we just subtract 9, and that's pretty much, subtract 9 minus 6, but we already know what, we know that there's 2 spaces away, so, or 2, is it 2? Why did I write 2? Oh, no, it's 2 ones, but 3 spaces away. So you just need to subtract 3. So this is 9 subtracted from 3. So 6 is your answer. And you just get rid of this one. I mean, you can also equivalent get rid of this one, but it's just one of these, right? It doesn't matter. And because if your k is 4, then the answer is 6. And there you go. All right. Whew. Hopefully that was a very long, good explanation. I mean, well, maybe I don't hope for the long part, but hopefully that was a good explanation. Reasonable. And then now we'll go over the code. But the code is pretty much all that we talked about. There is one extra case that we kind of skipped over, and that is max changes. Yeah, it turns out the max changes doesn't really come up that much. The reason is, let me actually come up real quick. The reason is because you can see that, so the max changes in a greedy kind of way, right? In a greedy kind of way, let's say you're looking at this one, you always want to just make one move to make 1 0 next to you a 1, and then the second move would be to move it to here, right? So that means that max changes allow you to spend 2 moves to move to the right, and it turns out everything that's not next to you, because that takes only 1 move, it's going to take at least 2 moves. So that means that you always want max changes unless you do moves next to you, which we'll go over. So that's basically how you handle the max changes, and we'll go over this now. Okay, so we have prefix sum here that we talked about. This is a regular prefix sum of the 0s and 1s that we get. And then here is the, let me double check that I'm showing you. Okay, and here is the sum of the indexes. Right, the naming is terrible, my apologies, but yeah, but this is the prefix sum of the indexes, so that we can use it to do the sum thing that we talked about. In the bottom, as I show you, it just goes over the brute force or try for each n or each I, right? Yeah, so it just we try for each I. And then now this is the big function. This is the big expensive function. We have to index, and I kind of did this in a funky way, and it turns out I didn't need this, but I wasn't sure that the reason is I handled it elsewhere, but it took me a while to kind of think about how I wanted to do, and I don't even know if some of this is strictly necessary per se, but I don't know. But yeah, but it makes sense in terms of just like being careful and getting every step of the way. So okay, so this is the first thing. If the index is already a 1, then you need one fewer. That's literally in the description. They tell you, so you just have to handle it. You could probably handle it another way. I mean, I'm not going to mention how you could handle it another way, but basically that's what I did. And then here, if you could go to the left and it's a 1, then you just do one move to remove one needed. Early return. Maybe this could have been a for loop. I don't know. Yeah. And then we try again for index +1. If it is, and so you just take the one from the right in a greedy kind of way. If we could do it, then you just take one move. Maybe I didn't need this, but the reason is because I want. So my idea, and I don't know if I could prove this, but or prove that you don't need it. But the reason why I needed it is because we need these moves before we do the max changes. And here is we take our max changes, like we said. We basically take all the max changes that we can with the needed. So we that's the number of because any like I said, max changes is always going to be your best move beyond the ones right next to it. So we already done the one next to it. So we're doing the other ones. So this is going to be delta, and delta times 2 is the cost of the moves because you take one move to make a max move to put a 1 next to you, and then a second move to move it to 0. And then I just kind of do an early termination just in case. I don't know. Yeah, and then this is the expensive, or not expensive, but the part that took me a while. Mostly, to be honest, I had alt 5.1 issues. It is what it is. But yeah, let me kind of group these up in a slightly better way. So this is the binary search, right? Very standard binary search code. I'm not going to go over the binary search code here because this video is already kind of running long. I made this end. It doesn't have to be, but it just kind of spans the entire array, and we kind of have have safeguards here so that it doesn't go out of bounds, which I kind of messed up actually in one place, which is why it took so long. But yeah, silly mistakes. But yeah, so this is just basically saying if we have enough ones. If going mid distance gives us enough ones, we try a smaller number, right? Because that means that we could try a smaller number to see if a shorter distance can give us enough ones. So this is standard binary search, and here is most of the money of this problem, right? And it's kind of what we already said, right? So we just count the number of ones on the left side and count the number of ones on the right side. So this is kind of awkward looking on the indexes, but the reason why I do this is that I actually ignore the immediate left because we already handled it. So that's why it actually is off by 1, which also threw me off a little bit. But yeah, but this is basically the things that we said with the binaries with the prefix sum, right? So you have this thing subtract from this thing to give you the number of ones between index -2 and index -1 minus t. Maybe I don't know. Maybe I'm off by 1, but basically that's the idea, right? That's the number of ones between that space, and the same thing for the right side. You could just input the index in, right? And we just check to see if we have enough. Oh yeah, that was the other typo I have, is that I forgot this conditional. That's pretty dumb. I don't know how that happened. And oh, that's why. Yeah, I spent a lot of debugging because I just returned this for some reason, and then I was tweaking the off by 1s out, or like I had most of this code. I don't remember. I think most of this was correct, but then because I just returned this was always true, so I just keep on getting wrong answers. So maybe That was pretty dumb. I forget. But yeah. Okay. So then now, after this conditional, the invariant is that left is equal to right, which is the distance that we should travel on both sides, right? And this is just the same thing as here. Just kind of so that I kind of have in both places. But yeah, let me kind of rewrite this here, right? So that this is number of ones on the left, number of ones on the right, right? And then this is sum of the indexes of the ones on the left, sum of the indexes of the ones on the right. This is kind of the graph thing that I talked about. So if you get confused about this, check it out again. But yeah, this is on the index prefix sum, which the variable name is terrible about, but yeah. And yeah, and then now on the left side, this is the thing that we told you about. So you know, on the left side you have this thing, and then you have some numbers. So then now you subtract the sum of the indexes, and that should be good. And then on the right side it goes above. So this is the sum of the thing, and then you subtract it by the average, and yeah, and that's the number of moves. And then now this is, as we said, if we have an extra one, then you just subtract it from the one from the left, or it doesn't really matter, right? Because they're both the same distance away. So this is the number of moves that you subtract, and then you return moves for that moves, and that's it. It's a lot of talking, isn't it? I need to drink some water. Hang on. But yeah, it's a long way of doing it, but you know, that's all I have for this one. Yeah. I'm gonna show you the code real quick again. So yeah, this is the prefix sum part. Like I said, this is a weird way of writing it, maybe, I don't know, but it saved me from writing the addition twice, I think. So I don't know. You could write it in different ways. I don't care. But yeah, and this is a very obvious loop. I'm not going to go over it. I already did. This is the entire code, but this is the handling the immediate index and the left and the right. This is handling max changes in a greedy way. And this is just a binary search to go see how far you get. Yeah, and this is the good function. Yeah. And then this is doing the math to calculate how many moves to get there. And yeah, we have an extra one, then we do an extra one, and then yeah, we return moves at the end, and that's it. That's all I have for this one. Let me know what you think. It took me almost an hour to do it, but like it was this bug that took me a while to figure out, and then I messed up where I had to off by once as a result after that. But yeah, but if you could watch this live video on like a faster speed to see how long I took to debug that, because that was so silly. But yeah, that's all I have for this one. Oh, let me go complexity. I didn't talk about complexity, did I? This is linear time, linear space for this part. This is linear time, and this is linear iterations, and this takes how long? Well, this tick depends on this, right? And here you can, so this function is, I mean, I kind of spoiled it in the beginning anyway. But yeah, this is O of 1. The binary search is going to be log n, and that's it. Everything else is O of 1. So this total operation is log n, and that means that this is going to be n log n, or this iteration is n log n, and that's pretty much it. Yeah, n log n time, O of n space, and that's all we have for this one. Let me know what you think in the comments. Please at least say some words of support if you're watching so far, because this is a lot of effort. I'm just so tired. A lot of effort to even just like say and kind of coordinate. So yeah, I would appreciate it if you leave a comment. But yeah, and now you could watch me solve it live during the contest. You could speed forward and kind of see where I made. A lot of the time is debugging, so I don't know. But if you're curious about those things, then you could watch it. But yeah, that's all I have. You could watch me solve it live now. I just don't know how to code. Oh, YOLO. Okay. Silly mistake. How am I doing? Okay, not 10 minutes yet. 68. I should have gone down earlier, but I should have been just doing sliding windows. I was just too lazy to do sliding windows. But okay, focus. one's gotten this yet. Binary nums. Who is Tilden Smith? Okay, focus now. Pick K1s from nums using the minimum number of moves. Just call it I. What are you doing? Select J where he's not at. Is that per turn? It's not clear where the max changes per turn. They don't really explain it. This is kind of crappy problem to read. Like they don't have anyone to proofread it. Okay, what's adjacent one such that and swap. Okay. Say what? Okay, so he started an index. Then he could pick one to flip, okay? Two adjacent ones, swap. If you swap it to where he is, if you swap where he is, the one to here, then it becomes 0. Okay, so basically like a distance thing almost, right? How am I doing? Yeah, the one penalty. Yeah, what a silly mistake. Alright, so you don't need, okay. Exactly K1s. And N is pretty big, okay. Max moves plus some K, what is K again? K is the number of ones. Alright, whatever. I mean, max changes don't make sense. You only do it for the next 2 years. It's not great though. That cute way mistake is going to cost me if I don't get this. But 0, okay. So you always have enough max changes to do it, but it's like a sweep line algorithm is probably how you do it. It's just like a confusing way of writing it, right? All right. How people submitted 35 already? Like, what are they thinking? Okay. I mean, I think I know how to do it. I have an hour. Whether that's right, that's another story. Or whether I can implement it correctly is another story. What is this, 7-pointer? Alright, I mean, trying to model this as best as I can. I think this is fine, but what? Yeah, I don't think I can get it. I don't know if I can get it correctly, but yeah. All right. You get that 2 moves. 2 moves means that everything has to be next to you, right? Up to max change number of times. And then it's the sum of all the numbers in between, right? All right, just do it. I don't know if this is right, or like, I don't know if this is good enough. All right. Because then it just becomes like case closest. It's like a very hard sliding window. If I didn't get that wrong answer, this would have been pretty good. This is pretty tragic, actually. Okay. Yeah. No, what are you doing now? Just do prefix sum. Okay, fine. It's been literally the entire week, so I guess that's fine. Okay, right. And then now for I and right. Can I do prefix? And now you have to do some funky things. It's like n square. Can I keep that in login? Okay, yeah, I guess that's fine, yeah. But then how do you get the numbers? How do you get the number of moves? So many edge cases. Yeah, actually, no, I can't do it that way. Search. I think I know how to do it, but it's so hard. One person got it. Good job, that person. Let's see. guess so. Just a slight leap abstraction. You just automatic picks it up, so it's one step away. That's just a summation, right? And it doesn't matter because we could do it afterwards. It's okay, fine. Actually, we don't need this then. Then max changes is the number of freebies. No, because each max change will get 2. We'll take 2. These allow us to get 1. Okay. Focus. Just do it, Larry. I don't know if this is good, but no, that doesn't do anything, Larry. Because it's on your search is a binary search. Okay, fine. I don't know. This is so hard to get correct, but alright, fine. No moves. This is so ugly. All right. And then now we want to do a binary search. This has enough. so this means that all the adjacent ones has been needed. So then now, for sure. Okay. Now, if we have enough moves, then we try a smaller number. And then the end left is going to be the thing. Is that true? Is my math right? Okay. Oh, you are getting it at least. Very smart people. Okay. So then now, we want the pre-prefix. Alright, I guess this is true. So this is zero. No. Oh, because the index is 0. Okay, that's fair. X is 1. Okay, maybe that's right. Alright, fine. Maybe I have to update it, but we'll see. Alright, now we want prefix of index minus 2. So we want this. I guess it doesn't matter as long as we're consistent. All right. Index 0, that is that true? It's 3 and 1 again. 3 is k, max change is 1. So I guess a 1, 2, and then we just max change already gets it. So then now, yeah, 1 and then 2, 3. Right? Okay, fine. And then this one is just silly. Yeah, that was just silly. But we could add more. Well, let's check the other one. One is 4. 1, 2. That one's not right. Oh no, left is 4, not the end is 4. We need 0. Alright, so then now at 1. Oh no, index 2, you need 1 more because why? Oh, you have 1 and then 1 max change, and then that answer is 1. That's right. Alright, so then if this is right, then right. Will I get it in time? I don't know. This is very easy to mess up, this one, I think. But 1 on the left. Alright, so then now I don't know what this means, but these are the sum of the index, and on the left it should be just draw a line this way, then it is going to be sum of the indexes. But it's also okay, 2x. What is x? X is in index. So then index times okay. That's the number of moves plus on the left, and the number of moves on the right is index minus alright, 3 and 4. I mean, I don't know. This seems sketch. I'm just gonna run it because why not, right? But it's not confident at all. Yeah, I mean, both of these don't have an the best answers were the max change doesn't do anything. So let me see though. 2 is 5, is that right? 2, we make 1, 2, 3, 4, 5. Okay, 3 is 4. 3, we make 1 from one side and take 2 from the other. Okay. Wait, is that true? Because what if we have exactly So what is the 3 looking at? 3, we have 1, that's true, but I'm scared that it is not right. 1 and 0. Is that just lucky? I think that's just luck. That's just off by 1 somewhere. That's not even right. 0, 1, 2, 3. What happens if we're exactly tie breaking? Why is that 0? I think I'm just off by 1 somewhere, to be honest. Index -1, is this right? I think this is more right. Nope. Oh, this is not right because this is not right. Still no. Three. So you need 2. Wait, oh, needed is 2. Okay. Oh, I messed up. So you have 1 move and then you need 2. Okay, so that's right. But if my max move is max change, if my max change is 0, let's just do a new case, then that case would be wrong. Though maybe it's not worth doing because that means that there should be another case where that is exactly equal. I'm not sure that's true. Well, -20 is probably not the right answer though, so we should do something about that. So lucky I did not YOLO submit, but it's still not great. So 0 is -20. Why? How does that even happen? 5 and 0. Oh, index -1. I guess this messes this up. Is this right? Because that means that everything is just wrong. Okay, I think everything is just wrong, but because index is -1 plus 1. Because we want the prefix sum not including the -1, so yeah. Man, I always get prefix sum wrong. Maybe. I don't know if I need for that one because I think that one's actually already wrong in a nasty way. Oh. Oh yeah, this one maybe is already off by 1, so it should be okay. Which is actually like a terrible thing to say, but I think it is actually true though. Alright, -19 is worse. I mean, not worse, but not great still. Alright, so we need one thing from the index 0, and we chose 1 as the bar. We have 0 from the left, which is fine, 1 on the right, which is good. That's not true. Oh, no, that's fine. Yeah. No, yeah, okay, yeah. 1, 1 to the right. No, I have to take care of this left G thing. No. 1 is just including this one, right? This is just wrong then. The left should not be 1. Index 1, 0. We needed one more move. And then left. How am I doing? Not so great, am I? A lot of people getting it. I feel like I know what I'm doing, but I just cannot get it right for some reason. Alright, left is 1. Alright, let's just look back at the original one. Okay. Okay, that's not useful actually. I have an idea, it's just like this thing is negative. Or something like that. But okay, 1, 0, 1. 1, 0, why? Well, I guess left is 0, right is going to be 1. There's this one. Why? Should be 2 minus 1. Oh. Am I looking at the right index? So this index is index of 0. Oh no, this is just the left. I have to look at the right. Okay. So the right, 0 plus 1 plus 1 is 2. Minus 1. So this is 1. It thinks that's 1 because it has 1 in there. So I do have to do an extra 1 to keep track. So this is the last element. I guess I should have to take care of it actually. Okay, fine. I should save all these things, but all right. So left is 4, which is actually what I expect, because just put nums. I don't need. Alright, so if 0, you have 0, 1, 2, 3, 4 space 4, and then now we have 0 and 1. All right. I don't know what they mean anymore, to be honest. 21. Oh. Oh, because this is silly. Okay, fine. I just didn't fix it, that's all. Alright, -5 is better. So 1 move. Is that true? For 0? No, because we won 3 things. So this is wrong. Because P right is wrong. It should be pretty big actually. Oh, I just didn't add the first one there. Alright, so this is 5, is that right? 1, 2, 3, 4, 5, okay. Alright, getting somewhere. Oh, 3, 4, 2. 3, 4 is 2, right? I don't know. But we can just check the math. For 0, this should be right. Oops. 0 is 6. Yeah, 1, 2, 3, 4, 5, 6. Wait, what? 1, 2. Oh, 1, 2, 3, 4, 5. So that's wrong. So 5. Oh, no, that's right. 6. Yeah. Alright, 1 is 2. Wait, really? Don't know. Alright, to so this is definitely wrong. We need 3, so this needs to become 1, 2, 3, 4, and then 5. So 1 should be 5. Why is this so close? Maybe. And close it up. Still have 40 minutes, I guess. That's good. Alright, so index 1, we need 1. We have 1 on the left, which is not right, I don't think. For 1. Right, 1 on the left, 2 on the right. That's not right at all. Oh, no, that's not what it's saying. I didn't print that. Alright. 1 on the left, I guess 2 and 1. Okay, well, it thinks, because it's doing that again, because it needs to be, so index includes, now this should be index -1 on the left. Wait, should it? Index -1, but we shifted over 1, so then prefix does not include. No, we don't want to include the index, so this is x minus, okay, fine. And then now we want to Alright, still very much wrong. Just print something here. Oh, because this is not matching this. This is what happens when you, yeah, no bueno. No, this one is kind of right. So we don't want to include the -1, okay. I think. -1 is always a bad sign, but how can that be -1? Oh. Still -1. Oh my, I am not so happy about this. But oh, this is good. This is 5. You have 0 on the left, 1 on the right, and the 1 is going to be 5. Yeah, okay, fine. Left move and the right move. Alright, so 4 on the right, okay. So then now 2, you make 1 on left, so then now you need 2. 1 on the left, 1 on the right. So 2 moves on the left, 1, 2, yep. 3 on the right, okay. And now how do I get this -1? Spot checking, everything sucks. But okay, 3, 1 to 3, okay. So then now here, we need 3 things. So this feels wrong with the answer is 2, right? Why is left 1? 0, 1, 2, 3. You needed 3 things, okay. And why is this 1? It should only give 2. 2 is right. 1 is going to be bad, right? Am I consistent everywhere? This is why you spot check, I guess. I mean, I would have gone 5-minute penalties anyway, but still though, not so great. Okay, looking for A3. Okay, so this is what we want, 0, 1, Y. This is the binary search. All right, let's just so bad, Larry. But we're making progress. I feel like we're right, but just have to get it right. All right, you have 5, 1 to 3, so 1, 2, 3. You have 5. It gives what? Oh, left, right, and left plus right. Okay, fine. So 2 on the left, 3 on the right. That's true. For 5, is that right? Oh yeah, that's right. Okay. And then you have 2. We'll give you 3. That's wrong. Should give me 4. Actually. Okay. Why is that give me 3? 1 on the left, so the left is wrong. So for 3, index is 2. We don't want, so index sum of index minus 1, but not including that index should be index minus 1, right? Yeah. Maybe the 0 is a little bit weird. I don't know. What is the index minus 1, and then is for 3 is gonna be 2. 2 minus 1. It's gonna be 1 minus whatever it is plus 1. This is 0, so 2 minus 0, right? 2 minus, so index is 3, so it's going to be 2 minus 0. So why is it giving me 1? Am I thinking about it right? What? Why not? Spending so much time on this debugging. Why'd I have off by once, Larry? Alright. 2 and 1. Oh, for 2, index, so 2 minus 1 is going to be 1. 1 minus, what is t? T is 2. So it's negative 1 plus 1 is 0. So why is that 1? So t. Wait, am I looking at the right thing? Maybe not. This is why you need side by side. This is so impossible to kind of dig into. Now the thing after the B, it's 2, 1. Well, it's still 2, 1. Why? What is this index? Am I just doing math really poorly in my head? Why is that 1? Index is 3. Oh, index is 3. 3 minus 1 is 2, minus 2 is 0, and then this is 1. Is that right? So this is the 3. I guess we just don't need the plus 1 on this side. Oh, I guess not. I don't know why I didn't try that though, to be honest. Alright. Still right for these. All right, let's see. I still think there's a bug though, so I have to double check. Okay, yeah, because all right, left, right, A3, left, right. This is actually wrong, isn't it? Still, this is I don't know what this is anymore. Index moves. Okay, so 3 is showing up as 4 because we have 3 here. Oh no, am I looking at the right one? Yeah, I am looking at the right one. There's 1 to the left, 1 to the right. That's not right. We need 3 moves, not 2 moves, right? So that means this function is off. Sorry that I'm not consistent, which is also possible. Need to do a better job about this. Okay, so this what am I doing? Wow, that is pretty bad. I pretty lucky that it got so far, to be honest. But okay, now the answer changed, which is maybe good, but let's see. Okay, so then 3, okay, now 2 2, and then now it has thinks it's 10. Okay, that's good. It's still wrong, but it's good. 5 moves to the left, 5 moves to the right. The reason why this is wrong is because, yeah. The reason why this is wrong is because it's counting an extra 1. Okay. How many people got it so far? Okay. I mean, this is just for pride now. Okay, so we have 2 2, but we have 3 needed, so we have an extra 1. How do I remove the biggest one? By definition, if there's a tie, that means that the last index is right? So okay. So then here I go if right plus is greater than needed, then we remove one of them, and which by definition, if it's multiple things are tied, then it has to be one of the extreme ones, which is to say index plus 1 or something. It's so then that means that the farthest is left plus 1 moves away, because we skip 1. Yeah, so then now we can subtract left plus 1 maybe. Okay, is this right? I don't know. All right, let's see. 3. Okay, and then now it's 7. Is that right? Okay, so 2 4 plus 3 is going to be 7. Okay, let's keep double checking. Maybe I don't need the binary one anymore. 3 4 4 is still probably good, I think. All right, let's check 4. This is why we check. I think, is it worth 5 minutes? I don't know, of a penalty. I'm not confident about it anyway. So 4, we need 2 because we removed this one. So then now we get 1 from the left, 1 from the right. So that's 1 plus 2 plus 3. So that's 6. All right, that's right. Here we get 2 freebies, and then we just get 1. Okay, fine. All right. I am not that confident about this one, but let's go. If it times out, I'll also be sad. Okay. This is a hard one for sure. For me anyway. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem on Discord or in the comments. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.